Is the screen is visible to all?
Yes, it is visible.
Okay, thank you. So let's start. Today, actually, we are going to understand the term that is normalization in DBMS. Normalization is a very important topic available in DBMS. It helps us to reduce the redundancy from the actual data set. Okay. Suppose we have a big data set, there are various kinds of dependency, various kinds of extraneous element, various kinds of multi-value attributes are there, but when you are going to actually perform some SQL query, there may be occur some error. For that error redundancy, we are going to understand the normalization. The normalization is the very important term available in DBMS. Okay. Now the thing is what normalization actually is. Okay. The first thing we need to understand that a large database defined in a single relation. What? The letter is visible to all or not?
Yes, visible.
I have to zoom it more. Now the letter is visible to all?
Yes, visible.
The thing is, a large database defined as a single relation may result in data duplication. Few seconds ago I told you that duplication may be occurred there. Okay. That repetition of data may result in making relation very large. That means just like the database has various kinds of duplicacy. That means the data set itself become very large. Okay. And one more option, wastage and poor utilization of disk space. When one value is used multiple times in multiple areas, it will take much more places to store. That means the data storage area we need more. Okay. For that purpose, like order error and inconsistent increases. For that purpose, we have to understand the normalization. Now the thing is, what normalization is? Normalization is the process of organizing the database in the relational database management system. Just read the first line and you can automatically understand the process of organizing the data. Suppose we have the raw data that is not fully furnished or fully organized. If you want to organize that data in a very good way, that means good way means there should not be any extraneous element, there should not be any error. The data set, whatever value will be there in every row, the row should be unique. That means the primary key idea, the foreign key idea, the relation, the dependency. We all need that knowledge to understand the normalization in DBMS. Okay. Now the thing is, normalization divides the largest table into smaller and links them using relationship. Suppose you have a very big amount of data set. Okay, suppose university management system. For that purpose, there are various kinds of attributes like student roll number, student ID, student phone number, student mail number, student branch, course ID, course name, subject name, and so many things move on. Okay. Suppose I am telling you just find the details of the ultimate or the exact area who belong from the cybersecurity department and he is from actually the third year. Then it is very typical. There are so many areas will be available there in all department. Okay. For that purpose, if we normalize the data set in a good way and we organize the data set in a unique way, we can easily find the area with the details from the whole database. Okay. For that purpose, we need to understand the normalization. Okay. If the table become now screen is visible to all?
Yes, it is visible.
Suppose we have a big amount of database. Okay. X1, X2, X3, Y1. That means these are the independent variables and this is the output variable. Suppose we want to find this according to the Aryan logic. Okay, if we just break that whole table into X1, X2 and Y1 and we just split the table into x, or x1, x2 and y2, and we relate with some relationship name. It will provide the better clarity to us. Okay, for that purpose we need to understand the normalization. There are various types of normalization is available. First one is first NF, second one is 2NF, third one is 3NF, and you can see the fourth one is 4NF. But in between 3NF and 4NF, one normalization form is available, that is BCNF or 3.5NF. The full name of BCNF is Boise coded normal form. I will tell you later. Okay, just understand how many types: first NF, second NF, third NF, fourth NF, and fifth NF. Sorry. Okay, first NF means what actually the thing we are actually applying in the first normal form is eliminate the repeating groups. If any kind of value of the attribute is repeating one more time, the first thing we have to eliminate that. Second is eliminate the partial functional dependency. What is partial functional dependency? You have your father and mother in your home, and you are the one child. Okay, you are partially depend on your father and mother. But in DBMS, when you normalize some big data set to organize in a very good way, there should not be any attribute who is partially depend on one and more attribute. There will be no partiality dependency of that. Okay, got it? Okay, now the third element means ki eliminate transitive dependency. Actually, I already teach you in the previous week classes that what is the functional dependency. Okay, now the option is fourth. Fourth means ki eliminate the multi-value dependency. Multi-value dependency means a value of a attribute that should not be depends on the multi-value attributes. Okay, and the eliminate joint dependency. If any attributes are jointly depend on others, we have to eliminate that, and we have to break the big table into the smaller table, and we have to connect or we have to link the our smaller table with the new relationship name. Okay, now come to the first one, that is first element. Okay, first element means ki first name means the full name of first name is first normal form. Okay, first name means ki a lesson or a table is in the first name if and only if each attribute contains only single value, that means there will be no multiple attributes. Okay, and that value is not decomposable into smaller parts. Decomposable into smaller parts means ki the multi-value attribute is not divided in the small value. We have to collect it from the different attributes or different cells. Okay, look at the, just for example, look at the table. What is the table name? Table name is known as the order details. And how many columns are there? Order ID, customer name, product, quantity and price. You can easily say that the order ID is the primary key of the table. Order ID is the primary key of the table. That means all tables should be dependent on the primary key. Look at here. Here one row, the order ID of 10102 and the quantity there are multi-valued occur. For that multi-valued occurrence, if you want to use the first name, you have to break the table in a new table, and we have to break the single cell into two rows. How? Look at here. Order ID 1001. If the product ID 1, quantity will be 2 and price will be 500. If one, actually in the previous table there are two multiple attributes occur, we just break that in a new way and it looks like a unique. And here, look at the here, product ID and product name. That means the first table, look at the first table very carefully. How many columns are there? 1, 2, 3, 1, on to how many columns are there? 1, 2, 3 and 4. Look at that. The product and order ID. How it is possible? देखो, order ID, that means product ID, quantity and price. Product ID, quantity and price will be depend on the order ID, and product ID will be implies the laptop, the product name, like laptop, book and pen. How it is possible? Using the first name. देखो, here is no multi-value. Here will be no multi-value attributes occur. The condition is we have to each attribute contains only single value, and the value is not decomposable into smaller parts. That is why here multi-value attributes occur. We just break that in a two table, and there will be no multi-value attributes happen. Okay. Now come to the second. What is second normal form? Now come to the second name. The full name of 2NF is second normal form. We can easily say that a table or a relation is in the second name if and only if the table is in the form of first name and the condition is full dependency. A full dependency means every non-key attribute is fully dependent on the primary key. That means every non-key attribute, only one primary key will be available in that table. Okay, and all the attributes will be depend on the primary key. देखो, for example, one more table is here: order ID, customer name, product name, price. Or look at here. Looks like this is a unique. Looks like this is a unique. But what is actually happening here? देखो, we just break the table into two tables, and here order ID, customer ID, product and price. These are the order ID, these are the customer ID, and these are the product, and these are the price. And we just break that table in a two way. One is for product, another is for customer. Okay, that means we can easily say that only one primary key will be available in the single table. Okay, got it? देखो, यहाँ पे क्या है? देखो, customer ID and customer name. In that table there are two customer ID, C1 and C2. For C1 there are two, but two products. If you break that in an order way, then we separate the two columns from the main table and separate the two columns from the main table, and we just create the another table, that is customer. So from the order details table, we just break that table in a two way, like in a order way basis and the customer way basis. Okay, for order way we just break order ID, product and price. All are depend on order ID because it is the primary key of the new table order, and customer ID and customer name. Customer ID C1 and C2, and customer name is depend on C1 because the condition violates that only each non-key attribute fully dependent on primary key. Okay, and the table itself will be in the form of first name. That means there will be no multi-value attributes and all non-key attributes fully dependent on the primary key. That is the actual idea of second name. Okay, now move on to the third name. Is second name is clear to all?
Yes.
Okay, thank you. Now come to the part is third name. Okay, what is third name? A table or relation. A table or relation in the DBMS is known as in the form of 3NF if and only if the table is in the form of 2NF and the one more condition, transitive dependency. There is no transitive dependency among the non-key attributes. Means if in a table, okay. If in a table, this will be the primary key of the table. According to the 3NF, all should be depends on the first column or the unique column of that table, and there will be no transitive dependency. How? This means A, B and C are the attributes. Suppose A, B and C are the attributes. What is actually happened there? A determines B and B determines C. Then A must directly determine C. How it is possible? Suppose you are dependent on your mother. That means whatever pocket money you will get from your house, that should be provided by your mom. And mom is dependent on your father. Whatever money your mom will give it to you, that should be coming from the father side. That means you are directly or indirectly, you are dependent on your father. That means it is the kind of knowledge of mixed function of partial dependency. Okay. What is happening there? Look at the example. Product ID, order ID, product name, supplier ID and supplier name. How many columns are there? 5. Okay. What is the condition of 3 and F? There is no transitive dependency among the non-key attributes. That means whatever table we are going to break the full table from the smaller parts of that table, there will be all attributes not transitively depend on the primary. Look at the example. We just break that table in a 2 and 3. Why we break the table in a 2 and 3? Because order wise one table we can create, supplier wise we can one table create, and product wise we can create the different table. And then all table become the unique table. There will be no multiple attributes, there will be no transitive dependency, and there will be no all non-key attributes will be depend on the only primary key attribute. Okay, look at that. Order ID, product ID and supplier ID. That means order ID, product ID and supplier ID, product ID and supplier ID depends on order ID. And look at the table. Look at the table. There are same product ID is occur and same supplier ID is occur. That means there will be no uniqueness. For that reason, we just break that table because it is uniquely identified according to the primary key. All keys are dependent on the primary key. For product, we just break that product in a simple way. P1 and P2, laptop and book. And for supplier name, S1 and S2, and the value will be same. That is why we just break the table in a simple way. Nothing that much. It is not that much typical thing. It's very easy. Just you need to understand what is the concept of non-transitive dependency. Okay. Okay, now come to the portion is 4th element. Actually, one more normal function is there, that is 3.5 and we are issuing we are washing for a normal form. I will tell you, just wait. At first I just teach you what is the 4th normal form. 4th normal form is a table or a relation is in the form of 4th element if and only if the table or relation is in the form of 3rd element, and one more condition, that is there will be no multi-value attribute dependency occur. Look at the just example. Okay, simple example. It is a simple table. Here will be one column is employee ID, another column is project ID, another column is skill. That means employee 1 with the project 1 they will have the skill like Java and Python. Even employee 1 with the project ID, maybe one employee can work in a 2 project with the 2 different skills. Okay, that is not actually happened in the 4th element. What is the condition? No multi-value dependency. Means any attribute multi-valuably not depend on the another attributes. Okay. So we just break the table in a employee wise and employee skill wise. Employee wise, what we have done? Employee ID with the project ID E1, P1, E1, P2, Okay, and employee ID with the skill. Okay, for employee ID the skill we just break it. देखो, all rows are the unique. Okay, that is actually the violation of fourth line. Just read the line. In this table there is a multi-value dependency between skill and project ID. For giving employee ID, so we are going to change the project ID for an employee and set the possible skill value. Okay. Now come to the question that is fifth name. What is fifth name? Fifth name means the fifth normal form. We can say that a table or a relation is in the fifth name if the table is in the form of fourth name and with the another condition that is there will be no joint dependency and the non-key attributes. There will be no joint dependency with the non-key attributes. Suppose we have a table. Okay. A, B, C. Okay. This is the primary key of the table. Okay. These are the non-key attributes of the table. According to the condition, both cannot jointly depend on each other. All should be individually depend on the primary key. That is the actual funda of no joint dependency. How? Look at the table. Customer ID, order ID, customer ID, product ID, quantity and price. And what we have done here for maintaining the fitness condition with the normalization portion, and we just take that whole table in a simple table, and the small table will become like this. What is order? In order, what we have done? Order ID with the customer ID. All rows will become the unique, and for order details, all will become unique. Okay, and we can say that all the conditions of fifth with the previous conditions, all is violated here, and we can say that the table is in the form of fifth name. Okay. Now come to the part is Boise coded normal form. Boise coded normal form means it is the extension portion of CNF or third normal form. That means the table should be in the form of CNF, and with the one more another condition that is every non-trivial dependency is a functional dependency. What actually that is? Just look at the example. Okay, I will just complete very quickly because time is up. Consider the following table: department, employee, and project. Here we can say department 1 with the employee 1, they are working in the project 1. Department 1 with the employee 2, they are working in the project 2. And what is the condition here? देखो, actually according to the condition, non-trivial dependency is a functional dependency. देखो, here non-trivial dependency is होगा. That is why we just break that whole table in a simple table, smaller table. Like we just break the table in a two table. One is for department and one is for employee. Department D1 and D2. Maybe one table can carry. What we are actually doing, what we have done here, we just break that whole table in a two small table. One is for department and one is for employee. Here we can say that department, employee and project. What is actually, I have just noted one thing, that is BCNF is a stricter form of normalization of CNF, and in practice the balance between normalization and performance considered is often solved. That means the balance of normalization to maintain the CNF at the upcoming version of 3.5 NF, fourth NF, we just use the 3.5 NF. Some problems are here. Okay, some problems are here, and I just give it to you. You just try to solve by your own. If any problem will be occur, I will solve it in the next class. Okay, and the thing is, there are according to the all functional dependent, all normal form, I just provide various examples. Okay, try to understand and try to solve some question. Okay, some question will be given here and try to solve all of these. Okay, if any problem will be there, I am here in the class, I will solve it. Okay, good day.